So welcome everyone. Welcome to our practical workshop on using R for applications, for practical application of network science. Now, that's my really warm welcome to all of you. We're going to have a fantastic time. We are going to have 2 days, 4 hours each day, and we're going to have a lot of practical things and a lot of R and a lot of network science. Now, so first, who am I? My name is Maria Prokofieva. I'm really passionate about using R. I'm using social network analysis in my research and a little bit of my teaching. So I introduced that into a business analytics course that we're doing. And so hopefully, I'm very passionate about using free open source environments in my research. So hopefully you are going to pick up on that, and you're going to build up some skills and knowledge that you're going to take from this workshop further. We did a survey for a before the workshop. Now we're starting with very introductory stuff, so we don't really want to scare anyone. So it may be that you are new to network science, it may be that you are new to R. So we are here all to learn. It's quite challenging to do workshops over Zoom, as you know. So, but, well, let's try and see how we go. Now, if you have any questions or if there is any unclear steps, you have no idea, you're feeling lost, please yell in the chat. Now, I do have a few helpers here. I do have my students from Data Analytics Association who are going to be helping me. Right, we will be able to move on. Now, I'm organizing the workshop in a way that we're going to have a practical session. We're going to have breaks in between, but I really encourage you, once we've done a very short introductory theoretical part, to open your R Studio and get your hands down with R and code along the way. So you will have enough time to follow me, and I really encourage you to follow. So rather than just sitting back and watching what I'm doing, I really encourage you to do things. All right? How does it sound? I cannot monitor chat like all the time, and it's quite challenging just to just go back and forth. So I will have some helpers who will help me with this, right? But so if you need to speak up, please speak up, right? As long as there is no really horrible noise, I'm not really particular about pushing you all to mute. So I really want to organize the later part of the workshop as a discussion matter, especially when we start working on your particular project. Sounds good? Looks like. So the breakdown of the session is that we're going to start with some very short introductory material, and then we're going to move to our studio, and we're going to dig into particular packages. Now we're going to work with 4 main packages. We're going to work with iGraph, StatNet, and gggraph and tidygraph. And then you're going to have, so for every package, we're going to go through some basic steps, and then we're going to implement those basic steps in a small project. And then for tomorrow, I do plan to do 2 or 3 practical projects, well, depending on how we go, where you will be able to complete a small project that implies the choice of working on network science in R with real-time data. Right? So let's have a look. So again, all the materials that I'm going to cover, all of the materials will be available later. So all the slides, all the code, everything, right? But again, in 15 minutes, we're going to open our studio and we're going to follow with the code. Sounds good? Looks like. So I am starting to screen share. Just give me a second. I'm going to my studio, organizing myself. right? And this is where I'm just going to share. All right, so let's have a look. Okay, how many of you are really big experts in network science, graph theory? Guys, unmute yourself. Let's talk. I studied not that long ago. Yeah, go.
I'm a mere practitioner.
Oh, well, what do you mean? When I talk to my, when I ask that question to my daughter, yeah, she's 12, and I ask her, network science, network, social networks. Oh, I'm a big expert. Which one? Twitter? Oh, no. Well, TikTok? No. Yeah, so which one? Which one are you practicing?
I study Twitter data and I build networks out of them. Less using social media, well, although I do that, but more studying networks based off of social media.
I'm planning to do a social media project for tomorrow, and you are given a choice between Twitter and you will be looking at LinkedIn, right? So like loads of opportunities there. Anyone else who wants to start digging into network science? Any newcomers?
I'm relatively new. I did a little bit in my penultimate year of graduate uni, looking at graph theory with applications to linear algebra. So looking at matrices with graph theory and stuff.
Perfect. All right. Anyone haven't heard anything at all? So it will make them feel comfortable.
I did some graph theory, like the linear algebra, but it was in the context of electrical circuit simulation.
Ooh.
And then also in finite volume methods, where the graphs, the connectivity of the mesh.
It's just amazing. It's just amazing, guys. Do you just listen to this? Say how wide applicable is the theory is. It's everywhere. And you can whichever area you bug, everywhere you can see that. In businesses, I've seen a paper recently talking about network science in accounting and connecting all different accounts, connecting flows. Logistics is really particular about that. So we're going to have a look at that. Jason is saying that he's new to network science, right? And again, yeah, you're quite right. So cleaning is really, it's really a big issue. Biology, everywhere. It's everywhere. So it's really widely applicable to everyone. But let's start. So what's this? That's my starting slide. And I think that's a really good idea of how network science looks like, right? So for some of them, so it's network science. You've got some dots connected with edges, and you're trying to read your future. So we are looking at the sky, and we're looking at all the zodiac signs, all right? So what the future entails us. So I think it's a really good representation of what we're going to cover.
Now, sorry to interrupt. Can I ask the slide we are seeing, I get the impression it might be cut, but it might not be, I don't know. So we are seeing from Aquarius, the top star kind of cut, and then the bottom. So yeah, I'm not really sure whether it's cut just for us or not.
No, it's just I think it's just the cut. I'm just trying to place. No, it's just cut. I'm just cut it that way because there was it's the image. All right. Let's move further. What's this? That's a transportation cluster, right? So we are looking at all the air flights that's happening, right? So, and again, so we see all the airports connected. That's another representation of what we're going to talk about. Now, so look, Zoom is playing up. What is this? People should be familiar with this. How that is connected. So my first slide was about stars and constellations. My second one was about air flights, right? What about this one? So when I see your smile, I guess you know the answer. So this is a map of an old city. And this old city is very, very particular. Well, it's from my motherland, Russia, right? But yeah, so like German people also have something to say. So it's from Königsberg. So what's Königsberg? Königsberg is a fantastic city at the outer edges of Russia, between Germany and Russia. And some time ago, like after the war, it was like decided to belong to Russia. But it's like initially that was Germany. Now, what's particular about this is the birth of the network science. And to start with, so how is it the birth? I want to show you one thing, and I really want you to wrap your brains over that. So let's move to the next one. So let's warm up. All right. I know it's with all these things. It's morning, but let's start thinking. All right. So what is this? That's a joke and a riddle. All right. So this is the Königsberg, and they've got a problem. So what was the problem? The problem was that they've got 2 islands, and to connect those islands, they have to have, like, they built 7 bridges, right? And the problem is, like, people are lazy, right? And they want to have the shortest route. They don't really walk that much. My kids tell me all the time, Mom, you're crazy. Like, who wants to walk when you can drive? So people of Königsberg, many centuries ago, they were as lazy as that. So the reason is, so that's the river, and red spots are the bridges. So how many bridges you see? 1, 2, 3, 4, 5, 6, 7. 7 bridges. So the task is, you need to find a route that would allow someone to cross all 7 bridges without crossing any of them more than once. All right? I'm going to give you 5 minutes. People used to spend centuries on that. All right? But 5 minutes just to warm up, just to see how we can go. So like you can start wherever you want, but for every, so you need to cut every bridge, right? But you cannot cross it twice. The person who's going to get the solution is going to have a big chocolate cake from companies, from organizers, from sponsors. Fantastic chocolate cake.
Well, I already knew the answer, but if there's a chocolate cake involved.
No. Are we having a chocolate cake? I didn't know about this at this point, Maria.
Well, but you need to have a solution to this solution, yeah. Right? So a solution of to find a route that would allow someone to cross all 7 bridges without crossing any of them more than once. So find that route and you'll get the chocolate cake. The chocolate cake is on the house. I'm the organizer. So Sivani, don't worry about that. All right? So any ideas, guys? Anyone want to brainstorm?
I don't think that's very fair.
Because you know the solution? It's a very famous riddle. I don't think that jetpacks are acceptable. No way, right? You have to cross the bridges. You have to cross every of those 7 bridges, all right? And you have to cross them all only once. So guys, so somebody like getting like really devastated and saying, no, there is no solution to that, all right? But let's see. Yeah, so yeah, you're saying somebody saying it's 7. Yeah, 7 is a fantastic number. All right. So let's see, like how, so we can go that way, right? So you return this, then go this, then go this. And what happens now? We've got here and oh, we're stuck. So yeah, so you can try all the possible routes, but there is a problem. So what's that problem? So that problem is related to a very, very famous person, right? So this is how I look in the morning when I sort of like, so that's Leonard Euler. And when he was asked about like somebody like you just suggested that riddle to him, and he was just, are you joking? So one of his quotes, this type of solution bears little relation to mathematics. I don't understand why you expect a mathematician to produce it. So guys, really useless, right? And he was like, he tried to solve the problem. He spent some time, he couldn't. Oh. And he was a very famous mathematician, very productive, like lots of books, right? And he couldn't solve it. He racked his brain, no answer. This question is so banal that seemed to be worthy of attention of that geometry, not algebra, right? So that's what we do when we try to make excuses. And he thought more. And finally, he found that there is no solution. And he produced a very big proof showing that there is no solution. And as Jan mentioned, yeah, it's just because it's 7 bridges. So no solution to that. And that mathematical proof was the very start of the graph theory, was the very start of the network science. We'll be talking about a difference between network science and graph theory, but at this stage, just assume that that's the birth of what we are doing today. So the very first theorem. Now, people of Königsberg was very particular. After Euler's death, God bless, they built another bridge. They built the 8th bridge. And basically that solved the problem, all right? So 7 bridges of Königsberg, the start of the network science. That's a bit of a history to entertain you. Now let's move further to what are we going to do? Why are we here? Why are we doing network science? I told you, it's applicable everywhere. You can just get it everywhere. You can apply it everywhere. And though earlier saying it's not mathematics, it's geometry, no, it's much more than that. Wherever you have a system and wherever you have elements and wherever you have connections to the system, that's applicable. The type of questions that you may want to ask, what are those elements? What are those relationships? And you know that 1 + 1 is not 2. You know that systems have value. And these are the elements and how those elements work together. The relationship between those elements that creates value in the system. What are the processes? What are the interactions that build a system? What are the key actors in the system? How information spread in a system? Who we should give them a vaccine so that we can start curing people? I think that's topical. All right, the first person in Victoria just received the vaccine. All right, was it the right person? Who was the wrong person to get the first disease? All right, so it's all the type of questions that you're going to ask. What are the dynamics of a change that you see in the system? What sort of system? Depending on your area, everywhere. What sort of change? Depending on your area, everywhere. What type of interaction? Depending on the area, everywhere. But these are the type of questions that you may be interested in. We will dig into them further in the second part of the day. For today, we're just going to cover some basics, right? How people, entities, structures, how they are connected, how they interact, how they change. Why do we need this? Which particular actor, which particular interaction do you need to affect so that you can maximize the effect, so that your magnitude of the effect will be higher, right? Let's move further. Application. So this is a fantastic. So applied everywhere. That's what we talked about. Human animals, perfect. Ecological communities, populations, perfect. Personality traits, perfect. Personal relationship, psychology, absolutely. Now I've got a very, very small map here. I don't really want you to show it like in big. That's your Melbourne rail network as we hope to see it in 2050. I still have some questions who's going to travel, because these days nobody really wants to get to the city because we're getting like really, really lazy in our suburbs, not really wanting to go to work. But let's see how we go. What is this? That's one of the examples of the social network linking, right? And it's a good idea to start going through some basics using that as an understanding. So what's this? That's the network. So how do we know that this is a network? What do you think?
There are entities and relationships between them.
Yeah, so we've got our nodes, right? So our nodes are people, and we also have some connections between people, all right? So like whenever you get to the linking, so you have all your connections. So these are all your connections. So you have nodes, and those are here, like people here. So what's the other term for nodes? We can use vertices, right? And we have connections, which are edges. So that poor Bob is not really connected. So we're going to talk about like what to do with him, what to do with him in the network. Now let's move further. Oh. All right, so we have collection of vertices and edges. So vertices V and edges E. We're going to use those notations, and you will see that I use those notations for quick check on your on summary of the networks that you're building in. All right. Now, so that's a bit of a less pictures representation of our previous diagram. So we've got X. So what is X? So we've got X as an edge connecting A and E, right? And A and E are our vertices, our nodes. All right, so that's our graph. Let's move further. So X is an incident to A and E. So some of the key terms that we will be using. So incident, all right? So X is an incident to A and E. So further, what's adjacent? So we've got adjacent, so adjacent vertices. So we talk about vertices, adjacent in relation to vertices. So these are the vertices connected by the edge. So we will be checking if our, so especially in bigger graphs, in bigger and more complex networks, that would make sense to use some code to check that. So in this case, so if we have a look at G, so let's have a look. So that's our G. So G is adjacent to which other vertices? So G is adjacent to D, G is adjacent to F, and G is adjacent to H. All right. Why? Because we do have some connections between them. So adjacency. All right. So and we'll be talking later about adjacency metrics. All right. And let's move further. Isolate. Who is isolated here? We've been in isolation for too long, right? Now we've got B, so that poor Bob, you remember, that person was not really connected to anyone. So B is isolated. Why? Because he's not connected to any other people, right? Very isolated. That's how I felt all 6 months, right? Now let's move further. What is the degree? So the degree is the number of connections that a particular node has, right? So if we look at node A, so what is the degree for node A? So node A has a degree of 2. Why it's 2? As a company, he has D and he has E. Now, B, so if we look at B, B is an isolate, and B has a degree of 0, not really connected to anyone. Now, F, where is F? That's our F. F has a degree of 4, right? So we will use the term degree later when we go through measures for the graph and when we are going to do some other measures. Let's further. Graphs can be directed and undirected. So the terms of it's very self-explanatory. We've got undirected graph where the direction of the edges are not set. So it's both ways, undirected. You go that way, you can go that way. So you can cross the bridge one way and you can cross the bridge the other way. Now, with your directed graph, you've got a very, very fixed set of rules how you can move, right? So A can move to B, but B cannot move to A, right? So directed, undirected. It will make sense later when we're going to work with measures.
Sorry, Maria?
Yeah.
Yeah, sorry. I had to look at the work email. So can you please explain the vertex and the degree again? Sorry.
Oh, yep, absolutely. So let's have a look. So we're looking, that's the degree, that's the previous slide, all right? So I have a look. So the degree, so vertex is the node, right? So this is our node A.
Yeah.
Right? Yeah, we're looking at node A. So node A, you see, is connected, so have some neighbors. So node A has some neighbors, neighbor B, neighbor D, neighbor E, and all other people there, right? But A is connected only to a few of them, all right? So who A is connected to?
D and E.
Yeah, so because there is a connection here. So that line here shows the connection. So A is connected to D and A is connected to E. But A is not connected to anyone else. I don't know those people there. Right? I don't know D. But I know D is a very good friend of me. And I do know E, very good friend. So those people who you know, that's the degree, right? So degree of 2. So A has a degree of 2. But here, B, lots of people around. But he is lonely.
Sorry,
Yeah?
what's the vertex again?
Vertex is the node.
Yeah.
Note that spot here, you see the A, that's the node, right? Node. So your node is there, like that's another term, vertex, or vertices when you talk about like in plural, right?
Okay, so they're the same. They're the same.
And you like well, you know, those mathematicians, they're just as bad as the accountants. They try to come up with so many different terms for the same thing to confuse you. Now, why I'm using both terms, just because when you start digging into packages, those packages, they do use their own terminology, right? For example, in iGraph, they use nodes, but in StatNet, they prefer to use vertices, right? So just that you know which particular, like that's all the same. So we are going to use them interchangeably, right?
Yeah.
Now, all right, Savandi, thank you so much. So guys, so in the chat, we've got a reminder, all right? But it's good that you ask, like, guys, that's definitely, I don't want to lose you, like you're halfway. So ask questions. So B, totally not connected. So who is the most popular person? That's the most difficult questions, like when you start a very practical question. So who is the most popular person in the network? What do you think? So we'll be talking about different degrees. We'll be talking about different degrees, but the obvious answer to that, well, probably that's the person that is connected to most of the people, right? And that's absolutely, that's F. So F, like if we have a look at connections for F, right? So vertex F is connected to how many other people here? So connected to this, connected to G, connected to H, connected to I, connected to E, not really connected to D, which is right. But so 1, 2, 3, 4, degree of 4, right? So we'll talk about that later when we talk about degrees of centrality, right? All good? Now let's move further. So that's our directed and undirected graph. That also makes a lot of like sense when you start talking, looking into those graphs later. So how can you transfer information in a network? For example, a very particular question, right? I'm a social media marketer, right? I've got all these people here sitting on the on my social media platform. Now, who should I need to collaborate with? Who is the most important influencer that I can give them my stuff and ask them to promote it and get across to as many people as possible, all right? Or if you look at your transportation network, what is the most important railway station? We're going to look at French trains later today, right? So train stations. What is the most important train station? They can go one way or they can go both ways, right? Interaction between people can go both ways or can go one way, right? I listen to you, you don't listen to me. That's the problem with my kids. Never listen to me, right? Interaction only one way, right? So directed or undirected. Now let's move further. Let me get back. We're also going to talk about the concept of a weight, right? So what is the concept of a weight? So the beauty of working with network science and network analysis in R is just because you can use attributes. You can assign attributes to both, to nodes and to edges, right? But at this stage, we're just trying to introduce that notion. So weighted and unweighted graph. So when we look at unweighted graph, so you see, well, you've got all your vertices, you've got your nodes, and you've got connections between them. And they're all equal, right? So from A to B is the same as from B to C. But is it always like that? No, sometimes it's not like that, right? Sometimes, like if you think about that as a distance, right? So you can think about A to B as Australia to New Zealand, and you can think about A to D as Australia to, let's call it Paris, right? Very different distance. So one of like how we can implement that other measures related to the edge is that we're going to introduce weight. So that's the very simple example is that it's a value representing the length of the edge, right? So the length of the distance. So that's our weighted graph and that's our unweighted graph. So weighted graph has some weights assigned to their edges. Does that make sense? But we're going to dig into that further when we start working with particular questions, right? All right, let's move further. How do we represent how we work with those graphs? So they look like really, really cool, and we're going to look at cooler pictures, but you know, those computers, those machines are pretty simple, pretty stupid. So you need to somehow take that image representation and put it into a format that your computers are able to digest, right? And the problem is that they mostly work with linear data structures, right? So how can we put that linear data structure so that they can understand what sort of graphs we have in our vision? Now, there are different ways how this can be done. The very, very simple way of doing this, it's getting dark here, it's the edge list. So what's the edge list? Again, it's back to the notion of edge, all right? So let's have a look. So what's edge list? So it's an ordered list of edges. So this is my very, very simple graph. So in my simple graph, I've got 1, 2, 3. So these are my vertices, right? And I've got connection between them. So all of them are connected. So it's a complete graph, right? So 1 to go to 2, 2 go to 3, 3 go to 1. So if I need to do the edge list, my edge list is going to show me what? Show me all the edges in the graph, right? So I've got my index here, and now I'm saying that A goes to 2, right? 1 goes to 2, 2 goes to 3, 2 goes to 3, and then I've got 3 that goes to 1, 3 that goes to 1. Does that make sense? So this is my edge list. I can present it as an array, and it's one of the way how I can input it. So edge list is just an array of edges that you have in your graph. To work with your edge list in R, you usually have to provide edge list, and you provide a node list as well. Your node list can come with attributes, additional parameters. So you can say A is red, 2 is, for example, like some other attributes, blue, right? So 3 is green. So you can use additional parameters there. Now, when you look at edge lists in R also can have additional attributes. Right? Now, looks very simple, but the problem is that when you start working with really, really dense graphs, that may present a problem. Right, so Tanjim, you're saying
yeah, sorry, I don't understand this.
Yeah, let's go. Let's do it again. Let's do it again. So edge list, all right? So think about edge list as a list of edges, all right? So I have a look. 1. So that's our graph. Are you looking at that?
Yep.
How many nodes do you see?
3.
Can you get a piece of paper?
Yep.
So get a piece of paper. And now 1, 2, 3. Now all the nodes that you see here, they are all connected. They may not be, right? There may be some missing, like isolates, all right? So let's have a look. So this first column, this is just an index, all right? So you remember you need to have some ID. Those computers really love IDs, right? So the first column, you just forget about that. That's your ID, it's numbered. It just like goes from 0 to whatever. All right, so
what's
the red one?
0.
0, it's the starting point. You just start counting. Oh, well, that's my first age, right? So it starts with 0. That's my like a number 1, ground 0. That's my 1, that's my 2. So what are you looking at? You are looking at edges. So nodes are here, and you forget about nodes. You remember, graphs are all about connections, all right? So we're talking about edges. Where are your edges? Edges are here. They are the lines. So we're looking at lines. So we're lucky enough in the sense that all our nodes are connected by edges. So let's have a look. What will be the first one?
So is that 0? The edge between 1 and 2, is that 0?
Yeah. So 1 goes to 2. That's why you're saying 1 and 2.
Yeah.
So here, your row just shows which nodes are connected by that particular edge.
Maria, can I interrupt? Is Tanjun having the question, is why are we starting the index with 0? Is that the question?
Why is the ID 0? I mean, I didn't know.
Oh, no, is that the
ID
question? That's what I'm asking.
Oh, okay. 0 is just like, it's usually they start with 0. All the arrays, they start with 0, right? You may start like with 1 if you want. Start with 1, right? So like whatever you start with doesn't really matter as long as you go sequentially.
Yeah.
All right. So you need to start with something, all right? So you start with 0. It's agreed, all right? And yeah, so Derek, yeah, you're quite right. It's just because array, like historically, arrays start with 0. It's just like, yeah, they decided to do that with 0. They can, like in their university, they can start with -1, all right? But in our university, they decided to start with 0. All right?
Okay.
Makes sense?
Thank you.
So that's the edge list, all right? So edge list of edges. Let's move further. Now, edge lists are not really that Cool. And this is where we're moving to agency list and agency metrics, right? So let's have a look. So we are looking at the very same graph, but now what is happening? We're organizing our presentation in a different way. Now, this is how we do this. So we just jump to agency matrices first. So what are those numbers here?
Nodes.
These are, exactly, so these are our vertices or our nodes, right? So we're just putting like all the nodes here, and we're just putting all the nodes over there. And now how we do our adjacency metrics, we are looking at if there is a connection or not. So if we look, so the first line is we've got 1 and 1. So we need to have a look if 1 and 1 are connected. So are they connected? Usually if you're connected, you should see the loop, right? But we don't have a loop, right? So that's why it's 0, right? Now let's have a look. So if we look at 1 and if we look at 2, are they connected?
Yes.
So 1 is connected to 2, and that's why you're putting 1. Right. Now let's have a look. 1. So if 1 connected to 3, 1 and 3 is connected. Yeah, it's connected. So we're putting another 1. Good. Now, so we're done with node number 1, and now we are moving to node number 2. Right. So again 2. Again, so node number 2. So let's see. So node 2 and node 1, are they connected?
Yeah.
So we're putting 1. Now 2 and 2, we don't have that loop here. So it's 0, all right? So 2 and 3.
Yeah.
So we're putting 1. All right? Now, if we look at number 3, so 3, so that's our last line here. So 3 and 1 connected, so we put a 1. 3 and 2 is connected, so we put 1. And there is no loop, so this will put 0. So this is a very, very perfect example of a complete graph, right? So this is where we've got all nodes connected. So complete graph. So we're going to look into particular special types of graph later when we are going to create some, but yeah, that's the one. So your adjacency matrix is usually the size of n and n. So that's your n number of nodes that you have in your matrix. Look in the chat. Yep. So if so, the question was really good question. So we've got 1 and 1, so n and 0, right? So like, can I connect to myself? I'm happy with myself, right? So if you're happy with yourself, you need to put a loop here, right? So a loop which goes 1 and goes here. So we don't have a loop here, and that's why it's yeah. So that's why loop with 0, right? Now, so that's your adjacency matrix. So adjacency matrix is much better for, but it can get like really sparse when you look at the graphs that are very complex. All right, now let's, with all the people bugging me on the emails. Now let's have a look. That's a little bit more complicated graph, but that's a real good example. So let's have a look. How many nodes do you see? How many vertices? So this is sort of a representation that I will be looking at, right? So I will be looking at 8, so your nodes list, and that's your nodes list. So showing you how many nodes you have in the system. And now you've got the edge list, and this is where you show all the connections. So your edge list is the array of those pairs of connected vertices. So 1 goes to 2, that's here. 2 goes to 3, next one. 2 goes to 5, it's over here. 2 goes to 4, over here. Now we've got 3 that goes to 4. right? And now 4 goes to 6 and so on. So that's our edge list. That's our vertex list, right? And now adjacent list. So what's the adjacent list? This is where we've got all the ones, right? So this is all the nodes that are connected. Let's move further. All right. So let's very briefly talk about those measures that we have in the network, and let's start doing R. All right. Now, questions that you may ask about the network that may be of interest. So once we've got all the basics, how large is the network? All right. Now, how densely connected your network? Do you have some distinct groups in your network? How compact is the network? Is it clustered or not? All right. And you all have all these measures that relate to your network. Graph measures, node measures, edge measures, network measures. We're going to look into those measures a little bit later when we dig into R and we start digging up particular functions that we can use. All right? But just to excite you, so this is how complex the network can look. Further, so let's start like very basic things, and then we just in a couple of minutes we'll be just digging into R. So some graph, some measures for your graph: size, number of members, nodes, vertices, or actors, right? And again, so that's used interchangeably. So you can use nodes, you can use vertices, right? Yeah, density. So when we talk about density, we're talking about the proportion of observed ties in a network to the maximum number of possible ties. Now, if you remember, like that 1, 2, 3 graph, we've got connections between all of them, right? So connections between all the nodes. So that was the highest density. Now, but it's not always the case. So that poor Bob was really lonely, right? So what we should do with Bob, all right? Now, we also have some other graph measures, and we'll be digging into a particular those measures when we talk about particular projects, when we go through functions. All right, we'll be talking about diameter, and we also will be talking about centrality measures, different types of centrality measures. I think we just leave that for a second, and we start digging into particular implementations with R. How do you feel about that? Right? So let me. I need to put my R on. So give me a second, and I suggest that you do the same. So do you need a break or anything? Guys, how do you feel? Do you need a break?
I think we can do a little bit more, like, since we haven't started our and all that, and then have a break in the middle. But that's me. What do people think? Yeah. Right. So I suggest that, yeah, so that we just go with that. All right. So I do have so we're going to start with R. So I suggest that we all go. Just let me screen share because I need to swap to my R Studio. So I'm going to, so again, so this will be like code long session, right?
Maria, you are mute.
Ooh, I didn't realize that, right? So I'm just going to go to my, so if you all can go to R Studio. So first, my first question, do all of you have your R Studio desktop? Do we have somebody who doesn't have R Studio?
I don't. Is there a link for that?
RStudio is a desktop application, right? So
Yep.
ideally you have it installed on your computer.
Okay.
Now, if you don't have, like, wait, don't stress. If you don't have it installed, I do have like a fix for that, right? So just give me a second. Now I'm going to screen share, and we're going to set this up for everyone, right? So if you have your RStudio, you just go to your RStudio, right? So give me a second. I'm screen sharing. No, I'm not screen sharing, right? So this is my RStudio. So if you have your RStudio, you open your RStudio desktop. If you don't have it, don't stress now, and don't try to, oh, I'm going to do that like in 5 seconds, right? It's going to take time. So that you can follow up what I suggest, can you go into RStudio Cloud and use RStudio Cloud for this video workshop? All right? It will look very, very similar to my desktop, so you can follow along. The only thing that you will need to do, so this is the link that I'm going to put in the chat. All right, so so if you can go to RStudio Cloud, all right, so go to RStudio Cloud. It will take you seconds to set yourself up. So you go, so what I'm doing, so if you're just totally new to this, so you go to, guys, can you mute yourself? Somebody's like really echoing me. All right. So you go to RStudio Cloud, and now you've got a quick link to sign up, right? So you go to the sign up. Again, this is just the case if you don't have a desktop installed, right? So you go to sign up, and you sign up for free, right? So they've got some limitations, but believe me, that's more than enough for today's workshop. So we go here and we click sign up. Right? And you can use whichever network, social network you want to choose, or just set up your email. It will take you 5 minutes the maximum. I'm very happy to wait and just go through some other things, right? Just sign up. They're going to send you the activation email. So just put whatever email address that you have access to, your password, first name and last name, right? For example, I will be signing up, let's say, with mine, Eva. All right, so you can choose whichever you want. And that's my working space at RStudio. All right. So how many people will be signing up with RStudio Cloud so that I know how much time do I need to wait? Oh, good. So if you're on RStudio Cloud, to make it look like my desktop, what do you need to do? You need to get your new space. So click on new space, give it a name. For example, workshop, all right, and just create. Oh, I have too many. So let's say that I will be using, give me a second, I just need to urgently. Wait a second. Right? So it will take quite a long time to create that workspace. So that's my workspace. I create a project. And this is like the routine that you're doing in RStudio for any sort of work that you're doing. So you're working with the project. All right, so it will take some time. right? So this is my project, and you'll see that will it's gonna look very, very similar. So if I just like remove that one for now, so it looks very, very similar to what I've got in my RStudio. Very, very similar to this, right? So you are in your RStudio. For my like further things that we're going to do, I'm using the R Markdown document, but I suggest to follow along. You create an R script and you just follow with the R script. All right, so we go to file, we go and create with the R script here. All right, and we need to give it a name, and to give it a name you just save it, and let's save it as workshop. All right, so this is where you're going to follow me. Right, so you either do it in your desktop, or if you are on the cloud, that'll be the same routine. So we're here on the cloud, you just go and you create your R script file, just to make it easier. All right, so R script, so we're going to save it. So you see, that's my project space. I'm going to save it, and let's say that will be my workshop. Right, just give me a second. All right, are we all set? Should we start? All right, perfect. So let's have a look. Let me close. I've got too many things. Now I am going to go. So the very first package that we're going to start working with, we're going to start working with iGraph, right? Very simple, very classic packages. So altogether, we're going to cover 4 packages. So iGraph, StatNet, these are the big ones. And StatNet is like really, really, really big one. So it allows you to do lots of things with your graphs. Now, and we also, so iGraph is a simpler one, but it's like still very, very useful. So StatNet, then we're going to move to gggraph, which is a newer addition, which allows you to work with visualization parts of your networks. Right? They're trying to use a grammar of graphics. They're trying to use all the visualization capabilities of ggplot in relation to graphs. And then we're going to look at tidygraphs, which allows you to use tidy data principles in relation to your graphs. And right, so we're going to cover these 4, and there will be some other packages which we're going to use in between, right? So if you haven't installed those packages, that's all good. You still have, like, you will have time, right? But the most important thing is that I want you to follow what I'm doing as not to get lost. If you are getting lost, you won't be able to do your projects at the end, right? So let's have a look. So we're here, we are starting our ground. Now, if you are, so the very, very starting point working with any packages is to have them installed, right? So those people who already installed, good on you. Those who haven't, we need to install them. Now, how we do this? Now, let's put, so I will put them back to back, right? So to install them, I need to go and type install packages. All right, and the very, very first one that I'm going to use is iGraph. So install packages, you include quotation marks, iGraph, and you just hit run. So install packages into your system. All right, so in my case, I already have them installed. So do we all know how to run? Right, so you can either, like, the cursor is blinking here, so you just press run. Otherwise, it's Command Enter or Control Enter on your computer, right? So it's installing it. Installation is quite simple. You may get some errors, like yesterday, so somebody sent an email about that error on Anaconda. So if you have some errors with installation, you need to tell us. All right. Now, once the package is installed, the next step is that you need to load the package, right? So just installing it is just on your system. To load it, you need to use library. So we'll put library and you put the name of the package, right? So iGraph. And you don't use quotation marks here. You just include that, right? And again, you need to run it. If you are on the cloud, you do exactly the same thing, right? So if you are here, just do exactly the same. Sounds good? So once you install packages, once you install those packages, you can like do whatever you want. Use whatever functions you have in those packages. All right. Now, iGraph is a classic package, and it's a beautiful package because it's been here for a while, and it has a lot of tutorials, a lot of resources related to that. It also has implementation in all different other languages as well. You can get some information. You can get information about iGraph. It's on CRAN, iGraph implementation for R if you go to CRAN. So again, so I will be providing you links, but just as simple as that, you just go to CRAN and you just put iGraph there, right? Now, you know it's installed. Have a look. Let's have a look. So you see what's happening? It's talking to you, right? So if we're installing iGraph, so it's saying, let's have a look, install packages. That's the command they ran, right? And now it's saying that it's trying to install, and now you see, oh, something happened, and it's installed. So I'm looking at the console window. You can see the console window in both in your RStudio, and you can see it also in your RStudio Cloud. So it's installed and it's there. But again, so the next step, so you need to do two things. You install once, and then the second thing, which is much more important, you need to load the package. So you need to use a library, right? So library iGraph. If you run a library and it's talking to you over here and saying, I have no idea what you're talking about, like cannot find that package, then it's not installed. It's not installed by default. So you always have to install it first. You install it once, and then you enjoy the benefits. Then you just need to use a library every time you want to use the package. Does that make sense? All right. Now all is good. Now that's my console. And so again, so can we move on? All right. So library, so everyone has it installed, right? So we can start doing this. Now we're going to start with a very, very basic things. So let's create some network objects. So let's create our graphs, right? So you remember we talked about different ways how you can represent your network, how you can represent your graph. So if we are going to do this in iGraph, we're going to use the graph function, right? So graph. And the graph function take some parameters here. So what are we trying to do in this first line? So that I'm looking at this line over here. So I'm using my graph function. So we're looking at the graph function, and now we're specifying the edge list. So edge list is 1 to 2, 2 to 3, 3 to 1, right? Now n is 3, and we're saying that directed should be f. So can we start? Can you run that line and see what you can get? So we're going here. All right, and I'm just putting that line here. and I'm running the line. Right? Now, once I've done this, so I'll have a look. I go to my environment, and I see this is my graph that has been created. So I've got one graph, right? And if I want to know the class, I just put class G1. And it's an iGraph object. Now, when you work with StatNet, you'll create a network class, which belongs to StatNet. Now, there is a way to convert iGraphs from iGraph object to StatNet, right? So quite seamless. So just try to run that, right? Right? To make it easier, so I'm just putting this in the chat so that you can copy and paste from the chat. Anytime you want to check what type of objects you've got, you put class. So this is the type, and if you want to get some additional help, you go to the help function, and you pull up the help file on this, which gives you, so if you haven't used that before, so that gives you all the possible options that can be used. So these are our edge lists. That's our number of edges, directed or not directed, right? And at the bottom, you've got all the examples of how you can use that function, right? Now, hopefully it works for you. So let's move further. So when we put class, right? So we know what class it belongs to. Now, what if I want to look inside my graph, right? So I just go and type G1. So if I go to my RStudio and just type G1, so it'll give you some notation of what you've got. All right. So let's have a look. So let's have a look at this notation over here, and let's read it. So this is particular to R, and this particular to iGraph. So this is the way that we specify the graph. So it's saying that it's our iGraph object, right? What is in this? It's undirected, right? Because we mentioned that it should be directed false, right? And now it's showing you your edge list, right? So it shows you, so you see all these lines here, the connection between 1 to 2, 2 to 3, and 1 to 2. Now, Simon, if you are having error that your object G1 is not found, it's most likely that you don't really have it in your environment over here, all right? So what you need to do, you need to run the line that I put in the chat. So how to run it, you just need to include in your R script. You need to make sure that your cursor is on this line and you need to run it. To run it, you either press this button here or you press Control Enter. All right. Tron, do you want to help? Simon with that?
Yeah, sure.
Yeah, I can do that too. Yeah.
Yeah, perfect. All right. So everybody else is all good, right? So that's the notation for the graph. Control Enter, yes, Derek, it runs only. So usually we just run line by line, right? We run line by line. All right. So let's move further. So, and now let's have a look. So if we want to have a look at our picture, we're going to use the plot function. Very simple one, right? So we go without any parameters, we just go and go plot G1. And again, I'm here and I need to run it. So I run it and I run the current line. So Control Enter, or if I just make sure that you have your cursor on this line here and you just place run. All right. Now let's have a look where I can see my beautiful graph. My beautiful graph is over here. All the zoom which you need to move. All right. So it will be shown under your plot area. So 1, 2, 3. There are ways how you can control your presentation. So if you want to change your notes color, if you want to change how your edges look, All of this is possible, but it gives you a very quick look at the structure of your graph. Right? Very simple. Now let's move further. Now let's create a more complicated one. So so we're doing it by hand. So that's my graph number 2. I'm specifying my edges. I'm saying, but have a look. So these are my edges. And now I'm saying that the maximum number is 10, and I want to have it directed. All right. So let's have a look how that is going to look like. All right. So I'm putting this in the chat. So this is like how I'm creating it. And now I want to plot it. So let's have a look. So how that is different from the previous one. So that's my edge list. 1 goes to 2, 2 goes to 3, 3 goes to 1. But I also have those isolated ones, isolates. All right. And again, I'm saying it's directed false. So they're not, so those edges are not directed. Make sense? All right. So I suggest that you create a G2 and you plot it. That's my plot function. All right, so let's create the second one. Again, I need to run it. So what's happening there? Oh. And let's plot it. Plot G2. Okay. So you should be able to see it over there. Right over there. Now, in my environment, so anytime like people not familiar with R, in my environment, I see these 2 graphs created, G1, G2, all right? So if you want to click on them, like they will not give you a lot of a visual representation as it needs to go in here, all right? Now let's move further. So these are some basic things. Now, can we create an empty one? Exactly, I can. So if I'm not specifying the edge list, I'm just saying graph empty. All right, so we've got a special function for that, graph empty. I'm saying that I want to have 10 nodes, and directed, well, it can be true, but in this case, they're like all the, like I don't have any edges. Now we also have some special type of those graphs that can be created. So that's our full graph. So what's the full graph is where all the edges are connected, graph full, and you just specify the number of edges, and you specify if it's directed or not, loops are included or not, right? And we can plot that. We can create some stars, which is special graphs, all right? So we can play with where where the direction is. So specifying mode out and specifying mode in. We can make some rings. And now we're moving on to a more notable graph, Zakari Club. So anybody heard about Zakari Karate Club? So this is the one of the textbook example that we're going to use. All right, it's a good graph because have a look, it gives you some space to work with. All right, so let's create our Zakari graph. So in this case, it takes a special like keyword, Zakari, right? So what's the Zakari Karate Club? There was a conflict between members of that karate club, right? And the problem was with one member, right? So that isolated Bob. So let's go to R and let's create that special graph. Let me put that notion in the chat. So if you can create that graph, Zakari, all right? So I have created mine, and I have it over here. All right. Now let's have a look what's in there. So if I pull it up, so the notation of the graph is over here. So what is it trying to tell me? What is 34 and what is 78? What do you think?
So the number.
Yeah, so 34 nodes. I've got 34 nodes, so 34 people in the class, in the club, and I've got 78 connections between them, right? So edges, right? So it's undirected. And now this one, so for attributes, so you see, I don't really have any additional attributes for that. We're going to work with them. So we're going to give attributes to nodes and attributes to edges. And now these are my connections between all of those people in the club, right? So do you want to plot it quickly? Right, so it's over there. All right, so that's our Zakari club. Let's move further. When we start plotting things, we can specify the vertex size and we can specify labels. So if you want to include labels or if you don't want to include labels, that's additional parameters that it takes, right? And again, I've got a really cheat sheet for you to see like how you read the graph notations. So directed or undirected. Now if you've got a name graph, which where your nodes have name attributes. All right, so we're going to work with those. Now you're going to have a weight. You may have some weighted weights in your graph as attributes. So weighted graph. Now, so basically, all right. So this is so let's have a look at more graphs. So far, we've been creating graphs using, like I said, we can also create it from the edge list. And this is where you're going to use this. So you usually start working with graphs when you have your data. And your data, you need to think about how you're going to organize your data and how you're going to supply your data to the graph, right? So one of the ways is to develop an edge list. So we will be doing the edge list when we work with the French train data set later, right? So we're creating a separate vector of edges, right? And we're supplying it to the graph and we're creating the graph. Now, this is the example of my named graph where I do have names like labels for my nodes, right? So have a look, so what is my graph? So in this case, I've got my nodes. I've got like 4 different nodes: chocolate, milk, espresso, and cream, right? And I'm saying that espresso, that's the name of the node, not 1, 2, 3. So espresso is linked to milk. So I'm using so directed graph here. So espresso is linked to milk. Now milk is linked to chocolate. So I've got cream and chocolate. And I've got espresso and cream going that way, right? And so I have this, so I'm putting it like as a name graph. And then later, that's another example, right? So in this case, you see, I'm not using I'm using edge list, but I'm using some special notations. So if I have undirected ties, I'm just using hyphens here, right? So hyphens will give you undirected one. So if I want to put a direction, right, I'm going to put plus. So you see, it looks like an arrow, right? So for pointing left. So this will be, so if I need to put a direction that way, So I'm just putting like this, and putting like and putting my plus on the right side if it's directly tied to the right. Right? If I've got symmetric ties, so ties going both ways, I'm just putting two pluses over there. Right? So my question to you. So can you have a look at them and spend the next 5 minutes and create a name graph with your family members? Right. So I've got my graph. So I have a look. I've got my graph with my coffee and chocolate and milk. So can you create a named graph with your family members?
Maria, sorry, would you mind scrolling back up your screen to show the espresso example as well, the code
Yep. So I'm just like use like you can like I'm asking you to create a directed graph, but I will keep it open, right? So it's all the relationship in your family, right? So I am going up. So that's my example. So I'm supplying the edge list, right? So I'm showing pairs what is connected to what. You can use this one, or if I make it smaller, then you can use special annotations for using hyphens. So that vector over here shows connection, so it shows your edge list, right? So espresso and milk, first one, milk and chocolate, second, cream and chocolate, third, espresso and cream, the fourth. So if you can do that, just we're going to work with that graph further, right? So there will be some further steps. So we'll be adding more things to the graph. So create that graph. I'll be playing with my chocolate coffee graph. All right, so like that far, I will make it available to everyone. All right, I just like want you to copying and pasting from this may not really work. So you need to understand what you're doing. All right, so you're creating your own graph. Anyone has some good luck on that? Daniel, do you want to show yours?
Maria, a quick question. So these are undirected graphs with double hyphens or single hyphens. It's the same, isn't it? Or is there a difference?
If so, like that. So if I'm going to go for this example, right? So if you just use, so if I just put hyphens, it's undirected. If I'm putting a hyphen here, so for example, let's do it like here. So I'm just taking my, that will be easier. So I'm going here, right? And I'm just saying that dogs chase cats, right? And cats chase mice. So let's have a look what's happening. You see, I'm adding a direction. So dogs, right? So dogs whoop, go that way to cats, and cats go whoop that way to mice. If I want to change the direction, I just change the way my plus is, right?
Yeah, thanks, Marina. The question is more on the number of hyphens. So sometimes you have 3, or sometimes you have 2, or sometimes
it doesn't matter.
you have 1. That doesn't matter, does it? Yeah.
No, it doesn't matter.
Okay, thanks.
Charles, do you want to show us? So somebody wants to show us your family tree, your family connections. So save that. All right. Oh, perfect. That looks like really cool. All right, so we're going to work with the graph later. So make sure that you save it as G6, which is perfect, right? So we will be working with that later. All right. So you are using the edge list. You're using the edge list. Yeah, then Jim? All good? Are we moving on?
Mine came up with no edge. So
No edge?
No line,
Sure.
so just the nodes. Why does that happen?
Can you paste your code that you
I
used?
can't do that, unfortunately, because I'm using another computer for our studio.
Most likely that you don't have connections because you don't specify the edge list. So if you look at my notation here, so I need to specify those connections, right? So here I'm specifying connections. So which one are you using? Are you using hyphens or are you using like those ones? Are you using vectors? So I'm saying that there is a connection. So are you specifying your vector?
Maria, you're not sharing your screen at the moment.
Oh, okay. Sorry about that. Let's just. All right.
So where is the list?
The list. So that's my list, right? So that's my array of the edges, right? So I'm saying espresso and milk. So it's like I'm really taking two.
Okay.
Right.
You have to do
so
it like
1 and 2. So you see, espresso goes to milk.
Yeah.
Right? And because by default it's a directed graph, so that's why it takes the direction like from first one to the second one. If I specify that it's undirected, it will be undirected. So there won't be any there won't be the arrow here. All right. So espresso goes to milk. So make sure that you use the
Okay.
Trong, do you want to have a look at that? Trong, do you want to can you help Tanjim?
Yeah, I can.
Yep, perfect. Thank you so much. Right.
Thank you.
So let's move further. So once you have your family, so hopefully everyone has a family now ready for us to have a look further. Now, there are also some quick ways to check what you've got, what's happening with your edges and what's happening with your vertices. So you can use capital E to get all your edges. For example, if I use capital E, so put capital E, and then in brackets put your graph which you create for your family, just to show up what sort of edges you have in your family. So in my case, I have a look. I've got a directed graph, and it shows that I've got how many edges. I've got 4 edges. So espresso goes to milk, milk goes to chocolate, and cream goes to chocolate, and then espresso goes to cream. So that's capital E because it's an edge. And if I want to know like what's happening with my vertices, I use capital V, and I put in brackets. I put the notation for my graph. Right. If I want to have a look at my adjacency like matrix form, then I just put the name of the graph and I put square brackets. All right. So that's my matrix. Do you remember? So instead of zeros, I've got like those little dots. Meg, those notes will be available. Just like I don't really want to share them beforehand, right? So like at least like so that you can entertain yourself, just going through all the fun, right? Definitely all the notes will be available right after we finish up the section, the session, right? So don't worry about those, right? Now, so capital E to get a list of edges, capital V to get a list of vertices or nodes, right? Now let's move on. So sometimes we need to count and see like how many we've got, especially that becomes important when you have a big graph and you look at some descriptives for your graph. So we can use v count and we can use e count to get the list. So v count, any ideas what v count is going to give us? Number of vertices, and to get number of edges, e count. All right, so run it on your family and see how many you can get. Usually the biggest question that you start digging into, you want to see neighbors, all right? So neighbors of your vertex, all right? So we've got some special commands for us to run. So neighbors. So when you specify neighbors, so what do? You specify the graph and you specify like what exactly, like which particular vertex you're looking at. So neighbors in a graph G, and we want to know neighbors of a vertex number 1, all right? So it shows you like who are they connected to, all right? So let's have a look at our Zakari club. So that's our Zakari club. So let's have a look at our Zakari club. So we're running, we want to know what are the neighbors for 17? What do you see? So can you find number 17? So that's my number 17. And do you see number 7? So I'm just digging up number 7. That's my number 7, all right? So that's my number 7. So, and now what I want to do, I want to get the intersection there, all right? So here. So also quite useful there. So neighbors intersection. Now, if you want to test is it directed or not directed, we've got some special commands for that. Are directed. Most you may get some edge lists, get edge lists, especially if you want to get some conversion between different formats for your graphs. So get edge lists. You can also retrieve your adjacency metrics. The most important thing is you can save your graph. So once your graph is there, you can save it and you can use it. You can put it on your computer. You can share with your collaborators and you can use it later. So that's my adjacency metrics for Zakari club. All right, not really representative. So what I want you to do now, just it'll work for you. You remember the family graph which you created? Can you run a command to get the number of vertices and edges in your graph? And the second thing, can you display the edge list and adjacency metrics? So a number of vertices and edges, and then display the edge list and adjacency metrics. All right, any ideas how we're going to do that? So we're just going to count, all right? So we're going to count vertices and we're going to count edges. So we're going to use v count, and then in brackets, you just include the name of the graph, and then e count, that will be for number of edges. You just include the name of the graph there as well. All right. So what about displaying the edge list and adjacency metrics? All right, so we've got the same solutions in the chat, v count and e count. And to get our adjacency metrics is just get edge list and you include the name of the graph, get adjacency and you include the name of the graph. All right. And we're working with the graph that you have for your family. All right. Are we happy to move on? Let's move on. All right. Again, so if you've got any problems with this, just scream out. All right. So we've got a couple of helpers here, so they will be happy to work. All right. Some couple of people need to, so yeah, so all the notes will be available. Sivandi, we may just have a little bit break, so I can push notes to you, just give you the link to the GitHub, so that you can post it in the chat and people can follow right now. All right. Now, but let's finish up that bit. So let's start looking at again. So we're going through very basic things. Right? It's just like important so we can move further. Now, the beauty of working with your graph in R is that you can add some attributes. So for attributes, you can add attributes to your nodes and you can add attributes to your edges. So these are additional qualities that you can attach to those basic construction elements. So if you remember my graph, right? So at this stage, I've got a name graph, which means I'm using names. And that's the same that you are using for your family, right? So your family graph has names. Now, I can, if I want to see what are the name attributes for my vertices, have a look what I'm using. Capital V, name of the graph, and name of the attribute that I'm referring to. So if it's a named one, it will have a name. So if I pull up name attributes, all right, it will show me my names. Now, I want to make it a little bit more complicated. So I want to add additional attribute to my vertex. So you remember my graph? Well, let's go back to my graph, my original one. So my simple graph with all the milks, right? So chocolate, milk, espresso, and cream. Now I want to add one more attribute, which talks about the fat content in all of them, right? So that attribute will relate to the node, to the vertex. So let's look how I'm doing this, right? So let's go back. So I am creating a new attribute which belongs to my node, and that attribute will be called calories. So what are the fat content? What are the calories? High, medium, high, high. How they will be assigned? They will be assigned to my names. So espresso will have which particular value? All right. Yeah, exactly. So I've got like these are all my vertices. So that's my list of vertices: espresso, milk, chocolate, and cream. And now here in the vector, I'm specifying values for additional attributes that I create for my nodes. So my espresso will have high calories, milk will have medium calories, chocolate will have high calories, and cream will have high calories. All right. So this is like the way for me to do this using the vector. So I'm referring to my graph, and I'm saying that I'm working with nodes, vertices, and here I'm specifying that new attribute. I don't really need to do any like new create or anything. I'm just specifying. So I'm putting the $sign. I'm saying that that will be my new attribute that belongs to nodes. And I'm putting the array of those values. I can do exactly the same thing with my edges. The difference here will be that I'm referring to edges, list of edges, and in this case, I'm specifying the attribute, which will be type. So type of edge, right? Again, I'm referring to the connection between the nodes. So in my case, nodes will have additional attributes and edges will have additional attributes. All right, so yumminess. So in this case, have a look, I'm like all of these are yummy. So I am assigning the same attribute, yumminess, to all edges. I can use a number as well. So in this case, have a look, I'm assigning weight. All right, so I'm creating the new attribute for the edge. Right, and I'm saying that all my weights will be 10. Basically, when you create a graph and when you create a graph from the edge list or node list, and again, this is where we'll be working with our French data set. So the first 2 columns in your edge list, they take as reference to nodes, and what you've got left will be assigned as attributes. All right. So this is the beauty that you can create automatically. You don't really have to edit later. Now have a look. So for us to examine, so once you create that, or once, so if you just imported your graph and you want to examine it later, that's what you're using. So if I want to examine edges for my attributes for my edges, so have a look what I'm doing. I'm using edge attributes. And specifying the name. So have a look. It pulls up. It pulls up all the attributes that I currently have for my graph. So for my graph with milk, I've got yumminess. So how many edges I've got? I've got 4 edges, and all 4 edges have absolutely the same attribute. It's not really like, I love them all. And the same, so if I want to pull up attributes for my vertices, I'm using vertex attributes. So edge attributes, vertex attributes. So you see, I've got some. So these are my names, and these are the that's the values for my attribute gallery. All right. And if so, if I do graph attributes, then it's just like they're referring to the whole graph. All right. There are different ways how this can be done. Right. So like I'm showing you all the possible ways. Now I've got, so you remember, you've got your family graph. So what if you add some attributes to your graph? So I've got my task here. Right. So you've got your family graph. So I want you to add additional attributes to your nodes, and I want to add additional attributes to your edges. All right. So for your nodes, can you think about attribute that you want to add? I suggest gender, but yeah, so maybe like a very difficult question these days. All right. So add attribute to the node. So that that should be some quality belonging to a person in your family, right? And should be generic so that you can assign a value. And then you have your edge, so connection between your family members. And this is where I want you to add attribute for the connection. All right. So you can use both of those techniques. So let me post in the chat, like the way how I'm doing this. So I'm just posting that example. Well, actually, you see it over here. All right. So in my example, Yeah, we just so in my example, so this is the easiest way to edit, right? So you reference to V when you have your note, and you specify a particular attribute name that you're going to use, and then in a vector you specify values for the attribute that you are setting. And then if you've got your edge, and if you want to create attribute, again you reference E, and then you put the graph name, and they put the attribute name, and then just like a particular like a notion or like vector, what will be then the values for your attribute. Now if you right, so I'm putting that in the chat. Alternatively, what you can do, you can use set edge attribute or set vertex attribute. So I'm putting that example in the chat as well. Right. So, and to delete, deleting is really like, deleting is very easy. So I am deleting graph attributes. Delete vertex attributes. So depending on what you want to delete. All right. So just add one attribute to your nodes in your family graph, and add one attribute to your edges in your family graph. And if somebody wants to show that, that would be fantastic. So I put all the examples in the chat. Now these are so the first two lines or the last two lines. So set graph attribute. Oh. Right. Yeah, so we've got a little bit more here to cover, and then we're going to have a break before we go to French train data set, and we're going to have a look at the real data set. First two lines are assigning graph attributes. All right, so do we need to wait more, or like somebody happy to screen share? Anybody wants to screen share to show us your family, beautiful one?
Well, I can do it if no one's willing, but like, you know. Yeah. sort of,
Oh, well, it's private information, right? And we're recording.
I know. So yeah, this is the other thing we wanted to ask people. We are planning to put all the recordings online, right? Sort of the videos. So yeah, I'll like, you know, I hope people are happy with it. So yeah, that's yeah, sort of that's one of the things. Yes, private information and all that.
What do you think, guys? So Sivanji, are you still happy to show your family?
Right. Okay. Give me a minute. I'll change the names.
Ah,
Okay. Yeah.
good. Person 1, person 2, person 3.
Yeah.
My dear loved one.
I can do it. I've put generic names in mine.
Perfect. Yeah, go for that.
So did you want to see the?
Yeah.
So what I've got is
if
a
you can
father.
just show us the plot.
Oh, so yep.
Show us the
I haven't
plot.
plotted it yet. I've done everything but plot it.
Yep, looks good. And you also, I see that you also set your graph attributes. So you set graph attributes to year, right? So which year you're well done, Tracy.
Thank you.
Now let's finish off this session so that we can have a look at the real data. Now let me screen share. Now we are here. That Zoom link is absolutely all right. So again, some little things. So sometimes we need to modify our graph. So we need to add edges and we need to add vertices. Oh, you're not seeing this. Okay. All right. So this is how we add them. So very straightforward command, add edges, where you specify the graph and you specify edges, and if you have list of attributes, you specify them. It's just easier to just add all attributes in one go rather than just to add them later. Add vertices, again vertices, and if you've got if you've got attributes attached to your vertices, you provide a list. So in this example here, we're making an empty graph. So this is the notation to make empty. So make empty, and we're specifying we want to have like 7 nodes, right? And then we're adding edges. So I'm adding edges, so providing the edge list, right? And then I'm adding edge attributes. So all will be green, and then I'm providing edge attributes, and I'm adding edges, additional ones, so between 5 and 1, and that will be a different color. All right. So we are using titeverse notation here. So people, if you're not familiar with titeverse and piping, so this is how we're doing this. So I'm assigning my graph to letter G. I'm creating an empty one, and then I'm using the piping notation over here to pass it to the next step. So this is my step number 1. I pass it to the next step, step number 2. That's my step number 3. So you see my piping function, and then piping operator, and then I'm passing it to next one, and then I'm passing it to next one. All right. So, and eventually, so I have a look, I am displaying edges for my graph. So what do I see here? So this is what I'm specifying, right? So I put some color, which is the additional attribute. So it was created empty, so there was like nothing in there. And then I'm specifying edges between those nodes that I have, and I'm adding attribute, which is color. So all the edges which I created, all the edges that I created on step 1, 2, 3 are going to be green. And now the edge that I create on the last step is going to be red. So again, that sign here is a piping. So it's move on to the next step. So do this, move on to next step, then do this, then do this, then do this. It's one of the coolest features that we're using in titeverse, just to save you time and straightforward your analysis. Right? Charles, I sort of, it just gives more detail. So I'm like, yeah, the question here is, so edge list, right? But I want to have more detail. So I want to show all the attributes that I have. So that's why I'm adding the notation. So you remember in one of the previous examples, I'm looking inside it, right? So, and here, have a look. So if I want to plot it, this is the way I'm plotting it. These are my attributes. All right, so how they are displayed. Okay, now let's move further. So I'm adding edges here in this example. Now I may also add some vertices, some nodes. So I'm taking my graph. So have a look. So adding vertices, I use add vertices function, specifying my graph and specifying what exactly I'm adding. So I'm taking my graph G, right? I'm passing it or piping it through to add vertices function. And you see, when you pass it through, you don't need to reference the graph, right? Because it's taking the graph and passing it to the function, right? So in this case, so what I'm specifying what exactly I'm adding, right? And I'm specifying the color for the for the node. So the color will be pink, and I'm specifying also adding more. So take my graph, add a node, and then on the next step, again, I'm piping it through and I'm adding an edge, right? And I'm adding quite a few edges here. And then I'm saving it to the same graph G, all right? So all right, we're going to have a look at our family. So this is what it creates. All right, so now let's have a look at the family. What I want you to do, can you add more members to your family? So yeah, so we're going to have a break. So just like that's the last bit, right? So can you create more members for your family? So what I want you to do, I want you to take your family graph and add vertices and add connections, all right? Think about not more kids, but your friends, include your friends. So add your friends as vertices and add connections between them. And that's the last bit. All right, so, and then we're going to have a break. And we're going to, I think we're going to move on to a French training case study because we're sort of a bit late. All right, so to add, so let's have a look. So to add vertices, to add additional nodes. So that's my example. I'm just going to put it in the chat. All right, so this is my GitHub repository. So you've got all my files over there. So we're moving into the second part to the case study when we're going to work with a French train data set, showing late arrivals and late, so all the connections in French train. So this is the link to the file. Just let me post it in the chat so that you can pull it up. Chat. I think right? So that's the IMD file with all the codes that you can just copy and paste from here, right? So hopefully it'll make it, but again, I will keep posting codes in the chat so that you can have a look and you can follow. Now we're going to have a look at a bigger example, which uses the real data. Now let me go to, just need to move Zoom a little bit. All right. So we are going to have a look at French case study, French trains case study, and we also, right, and we're also going to have a look at visualization part. So this is the part which we skipped, sort of skipped in our previous part of the basic manipulations, and we're going to have more time to have a look at visualizations. We're going to dig into visualizations a bit further, I think tomorrow morning, when we're going to start with gggraph, and it gives you much more flexibility in terms of what you can do with your graphs. Right. So again, so there are quite a few other software available that allows you to visualize your graphs, but what is good about R is the flexibility that you have and the power that you and control that you have over your graphs. Right. So now let's have a look at that French case study data set. So it's the data set we're going to use is part of the Tidy Tuesday initiative, which they run. So let's have a look. So they let's have a look at the data set itself, and let's have a look at Tidy Tuesday. So Tidy Tuesday is a fantastic project run by the R community. So Tidy Tuesday. So it's a weekly project, and every week they publish a data set. So that public data set comes from a real data. And the beauty about that is that it's not only like it's real data, that it's some sort of cleaned. So you don't really have to do all the heavy lifting on cleaning your data sets and dealing with lots of missing values, imputations, and that's the really right. So it's pretty clean. So every week you've got a new data set for you to have a look. So I really encourage you, if you want to get some more skills in wrangling your data, to participate in the data set. So you also can have a look at things that's been done previously. So they keep all the data sets for previous year here, right? So you've got 1, 2, 3, 4 years of data sets, and like that's 52 data sets for each year. Now we'll be digging into one of the earliest data sets which they made available. I think that was 2019, when we'll look at French trains. Right, so what's that French train data set? They look at all the connections in France for a number of years, and they recorded some data, some available for transportation networks in France. So that all the data is real data. It comes from National Society of French Railway. Now they do have a portal, and where you can get that information. So it's available publicly. There are no ethical issues. So everything that Tidy Tuesday is doing is covered. So it's all like available, publicly available information. Now, in that data set, we are looking at 2 files. So National Society of French Railways, they've collected data since 2098, but we're looking only at the recent edition. So we're looking at the last 3 years. So we're looking at 2015 and 2018. Now they do have quite a number of train stations and routes between those train stations. Now the full data set includes, the data set for the Tidy Tuesday includes 2 files, full trains and small trains. So their small trains is still a big train data set. It's just like the number of additional information that they provide. So we're going to start working with a small trains data set, which has only 13 columns, right? Now let's have a look. So what will be the first starting point? So first, so far we've been working with very basic steps of creating our graphs from the scratch. So now we're going to create our graphs like in real life of what you'll be doing, creating graph from the data set which you are provided. So let's have a look. So again, so you are following me along because again, so all the links will be in my, yeah, it'll be here, right? So if you can just scroll down, so I'm just on this part here. So you can go straight to my code and copy and paste from my code, right? So you see, like, yeah, I'm using R Markdown. So these are the links in between. So let's have a look. So first thing, we need to import our data. So, but to be able to import our data, we need to make sure that we have all the libraries available to us. So again, so you go to your R script file, right? So R script file, you can create a new R script, or you can just follow of what we've got. And so for data manipulations, we'll be using titeverse. So you need to make sure that you have that you install the library titeverse and that you load the library of titeverse. So again, so previously we include a library iGraph. So now can you please make sure that you do have this line, install packages titeverse. So titeverse is a collection of packages that includes quite a few different other packages that allows your data wrangling and tidy data manipulations. So install packages titeverse if you haven't yet done so, right? Oh. And don't forget to run that line, and then go to include as load as a library, all right? So I'm including it as a library. Again, I'm going to post, so I do have it in my file over there, and I'm posting it over here in the chat so that you can copy it here from chat without really going. All right, just make sure that it's loaded, because otherwise you won't be able to start exploring the data set. Again, this is assuming that that you already loaded your iGraph library. All right. All right, just give me a second. Ryan, can you just reload it? Just reload the document. All right. So let's go and have a look. So we loaded the document. So we loaded now. Guys, can you hear me?
Yeah, we can.
All good. All right, just because my AirPods just died. All right, just making sure that you still can hear me. Okay. So now we loaded the data set. Now let's have a quick look at what we've got. All right. So what we've got here, we've got quite a few variables. All right. So let's have a look at them. So our small data set. So let's go to small trains. So small trains data set. So this is what we've got. We've got years, we've got months of operation. Now we've got type of service, national or so we've got national. We can have international. Now we've got departure station and we've got arrival stations, right? So any ideas? So departure station and arrival station will be our nodes, will be our vertices, and the connection between them, routes, will be our edges, right? We also have some journey time average. We've got total number of trips, which we can use to assign our attributes. Now we've got average delays at departing and average delays at arriving, right? Number of late departures, number of arriving late, delayed calls. So it gives us quite a bit of flexibility in terms of what we can do with the data set. But we start with just like we just loaded it. So we cannot really, so as it is loaded, so let's have a look. So we've got small trains. Now, if we just run the class on this, this, small trains, right? So you see, it's not my iGraph object. I need to do some manipulations to be able to convert it to a graph format. And usually manipulations to get your data set ready for the graph, that would make a lot of time, right? Now, so we are going to do the exercise when we create a node list and we create an edge list, right? So what are we going to do? Our nodes list will be our stations, right? But we have departure station and we have arrival stations, right? So we need to think about how we're going to manage that. Well, ideally, we can get all the unique notions for departure stations and just make them nodes. But there may be some departure stations and arrival stations, which are not arrival stations, all right? So we need to take departure stations and we need to take arrival stations and we need to prepare the full list of nodes, possible nodes. Does that make sense? So how are we going to do this? So we are going to use titeverse manipulations for this. So we're taking our small train data set and we're grouping them by departure station. Why we do this? Just because I want to calculate some other metrics that I will be using for my attributes. So those will be my attributes for my nodes, right? So what I'm doing here, I'm grouping all of them by departure station and I'm calculating, so I'm creating a new variable using mutate function from titeverse. I'm creating a new variable which is called late depart and I'm calculating average number of late departures for every single departure station. All right. So eventually I'm going to use this as an attribute for my node. Another variable that I want to create will be my late arrival, right? So a late arrival for each departure station. So I'm using the same mutate. So I'm just putting it as 2 lines here, right? So this is the first variable that I'm creating with my mutate. And this is the second variable that I'm creating with my mutate. So late arrive, and I'm taking my mean on number of arriving late, the variable from my data set. And then just I'm ungrouping them. All right? So those are mean values for each departure station. All right? And then once I calculated those extra things, what I'm doing, I'm taking my small trains and I'm creating a list of unique distinct mentions for my departure station. And I also want to include service because if you look at my data set, some of those stations, so the same station may be used for international service and may be used for national service. So the status of that departure station will be different. All right. So I am saving that as my roots from data set, so extra data set that I'll be using later. And I'm also saving some nodes attributes that I'll be using later. So departure station, late depart, which I create here, and late arrive, which I create here, that I'll be using. So departure station is basically will be my nodes, and late depart and late arrive will be my nodes attributes. All right. And if I have a quick look at that, So that's what's been created. So these are my nodes, and that's my additional ones that I will be using. All right, now let's move further. I also have my arrival station that I need to look after, right? So I need to make sure that my arrival station will also be in the full list of nodes. So I'm taking like that step is basically I'm just repeating the same. So I'm taking my small trains and I'm running distinct on my arrival stations. And again, I'm just want to be particular, so yeah, just renaming it to labels because I'm going to join them later. So arrival station. So it matches my label over here with departure station over there. So now I've got my list routes from, and I've got my list routes to with departure station and arrival station. All right. And now I'm going to join them. Now, do you need time to do those steps? So you have your file on GitHub, and I'm going to post it in the chat so that you can copy from the chat as well. Right? So this is the first bit, and now this is the second bit. Right. Because that will be assigned, so eventually we'll be matching them. We'll be matching so the question. So we're matching departure station station list to, so like it's the, if you look at the website, it's the where the route starts. This is how they define if it's international or if it's national. All right. So now we've got these two lists. So what are we going to do? We do the full joint, right? And we've got our nodes list. So again, full joint gives us the nodes list. So we've got nodes list, and the nodes list will include our service as well. So in this case, that national or international will be the attribute that we'll be using later. That relates to the station itself. All right. Now let's give each station, let's give each station a unique ID. So we're going to use a row ID to column. So adding ID, but we can work with IDs later. So it'll be easier. All right. So this is like, yeah, this is where we create. So this international routes usually have preferential treatment. So eventually, like when you are doing your analysis, we'll be able to have a look at that. All right. So we're looking at those attributes. Now we've got our nodes data set. So we're moving further, and we need to create the edge list. All right, so let's have a look at the edge list. So these are all the stations, and these are the service type that the station has. This is the status of the session of the station. Now let's move and have a look at the edge list. So how we construct the edge list.
So we take our small trains data set, and now we group them by departure station and arrival station. And we also want to calculate some additional attributes which we will be using later. For example, we can have a look at number of trips. So average number of total trips that go from that particular like route, just because we're grouping by departure station and arrival station. And we also can have a look at the average journey time for that particular route. So journey time average. So in this case, I'm using summarize. And let's have a look. So this is the data set that I have changed. So I do have departure station. I have arrival station. I've got a number of trips, which is the average number of total trips along that route. And I've got the journey time, the average journey time per route. Right? So again, so nodes lists are done. So now we're dealing with the edge list. Right, so I'm posting this in the chat. Right. So just give you a couple of minutes to finish that bit. Right. So if we have a look, so this is what we created. So we created a data set which have departure station, arrival station, and our variables which we created, which we're going to use as attributes. All right. Now, what do we need to do? We need to somehow convert it, because like in this form, we cannot use it. All right. So it creates, so like you see, we've got labels, but not IDs. So how can we do this? So let's have a look. We are going to take our data set, and we're going to join it with nodes, and we're going to use a left join. So we've got labels, which we're going to use, right? But we're going to rename it to IDs. So we do left join using departure station, and we're using, again, further, we're using arrival stations to match it. Right, so let's first that bit. Okay, Noor, will be with you. So Noor, I've got a couple of people who are lost, right? So I think we should be like, just let's refresh. Right? So once you install, so again, so we lost a couple of people like from the very start of the example. All right, so let's have a look what exactly we're doing. So once we loaded packages, the next step after you loaded your packages, so you install your packages and then you use a library to load them. So can you just all make sure that you have library titeverse done and library iGraph loaded as well, right? So once you've done that bit, we're starting working with the data set. Right, so what we need to do, so let's do, so I'm just like, let's refresh. So first we need to load the data set using a read CSV function. So I'm using a read CSV function from titeverse, and I'm using the internet link to the CSV file, which belongs to Tidy Tuesday GitHub repository, right? So I'm putting a read CSV, and then in brackets, I'm putting the link to the file, right? So I will done that step. So those people who are saying that they are lost, so I think I've posted like it earlier in the chat. All right, but let's again. So if you're lost, so first you won't be able to do anything unless you have your data set loaded. Right? So we loaded the data set, and then we need to do two things. We need to create node list, and we need to create edge list, right? So the bare minimum will be just to have names of those stations and for the nodes list, and the bare minimum will be to have edge list, just connection between those stations for your edge list, right? We're trying to add a little bit more of a detail there to add attributes and to work with attributes, just to show that we can have attributes, right? So this is where we're moving down, and we're just trying to do that step over here. All right. So so people who are lost, are you able to grab the code from the chat? Or do you want me to post it again?
Maria, a small thing. The thing is, on the network, on the GitHub repo, we can't. I mean, I can't see for the HTML file. We can see the RMD. I can see the RMD, but the thing is, if people are not really familiar with RMD, they wouldn't know how to copy, like, copy parts from there. So the HTML would be really nice, but I can't see the HTML. I don't know whether that's a way for
Just
other
give me a
people.
second. I'm just going to push it now. Just give me a second. So I'm just pushing in that HTML to GitHub now. Right. So Sivanji, are you able to see that file, or just push it to GitHub?
Hold it. Can I show you what I can see? So.
Oh, absolutely, absolutely.
Yeah. So share screen. So I see this, and then now the HTML comes up, and iGraph2, when I click, I don't see the thing. So maybe if I download,
it's
and then getting sort of maybe
I just need some time to put it, because like the idea is just that all materials will be available after.
Yeah.
Right? So just
yeah. Okay. That's okay. Yeah. I'll stop sharing. Yes. Yeah, let's move on as long as you're copying and
Yeah, so
pasting the code.
I'm
Yes,
going
yeah.
to, like, for tomorrow, I will put that as HTML file, right? I just want to move on and cover the material. Okay. Now, so let's have a look. So are we all, like, you hopefully all of you had time to, to pick up where you left, right? So if anyone has a problem, just don't wait for too long. Now we're going back. Now let's have a look. So let's have a look at the visualization bit. And let's create our graph now. So we've joined. So where we left, we did the full join. So we've got our nodes list now. And nodes, so nodes lists are done. So we've done the edge list as well. So that's our edge list. So when we do all the joins, and this is how our edge list looks at this stage. Let me zoom around. All right, so we've got departure station, arrival station, number of trips, journey time, and now we've got our IDs, which we're adding, right? And we've got service. Now let's have a look. So what are we doing now? So we are selecting, so for this particular route, so we are selecting only the variables that we're going to use. So we do need through, from, to, which we'll be using. And then we've got number of trips and we've got journey time average, right? So this is our edge list. So when we're going to supply the edge list to the eye graph, it's going to take first two columns as the actual edge list, and last two columns, so whatever extra you provide, will be taken as attributes, right? And basically, this is what's going to happen with your nodes list. So if I go back to my nodes list, right? So that's adjusted nodes list over there, right? So now if I go, so now let's create. So let's create the graph now. Let's create the network object, all right? So especially with edge list, but before we create, especially with edge list, so you see I'm changing the order of my variables just to make sure that first two columns are the actual edge list. Because you remember, so it's not gonna like make a decision what are where exactly is the edge. So the first two columns should be your edges, right? So that's my edge, and these are all additional attributes that I'm using, right? Now let's have a look. So to create my edge list, I'm using a graph from data frame, and now here I'm specifying my edge list. I'm specifying my vertices as nodes, which is the variable that I've got, all right? And I want to make it directed, all right? So that's will be true. So I am creating my graph, roots graph, right? So I'm using graph data frame, which creates me my data frame, which creates my graph. Right now, if I check that, so that's the iGraph object, and I can see all the notations here, so that people can do that. So let me post that bit in the chat. All right. Yep. So anyone have issues with that? So everything is working. So this is my root graph object. So let's have a look. So how would I read this? right? So if you've got confined function, it's likely that you haven't loaded your library, iGraph library. Ron, can you have a look at that? Just make sure, Norman, I have an issue with that, with loading libraries. So can you just make sure that library iGraph is loaded? So Alireza, so if you don't have your notes found error, it means that you sort of skipped that step. You need to go back and actually create the file with notes. So I'm creating the file with notes over here with all the steps when I create my node list. So I suggest that the easiest check for you would be to have a look at your environment and having a look that you actually have your notes variable over there. Right, so those people who have issues, can you just talk to me? So we need to create the graph because otherwise we won't be able to do visualization. Right, so let's have a look. So it looks like a couple of people have got issues with creating the graph, creating nodes. So let's have a look. So this is where I create the node list. Just let me post it in one go so that you can just copy and paste from there. All right. So these are all the steps for creating nodes. So I've got a couple of people who have issues, nodes not found. So you need to run those commands, right, in your RScript file to be able to get that nodes data in your environment. So if I look in my environment, so once you're done, right, so under your environment, there should be nodes, should look like similar to this.
Sorry, Maria, for me it's there, but still it says the D is not found, the object D.
Object what?
Object D is not found.
Maria, I'm having the same problem.
Object D. But you need to specify, because have a look, the actual command that I'm putting there is here, right? So this is the command when I'm specifying that I'm using D as my edges and vertices as my nodes, right? So hope that are you running this one?
Yeah, it's already done, that part, but it still gives me the error.
And it's showing that no. This is like a Ben. What you're showing me, like you're showing me this bit here. This is the general format for creating your graph from the data frame. This is where I'm creating the object, right? So, like the one that I've posted. All right, so like the one that I highlighted over here. All right, thank you, Richard. Yeah, that's exactly what I meant. So can you just have a look at my highlighting bit that I have over here? So you just run only this line. This line is just to show you what is the syntax of the command. So like if you want to create any other, like any other graph at all, so what you need to supply, you need to supply only the edge list. Basically, you don't need to supply your vertices. So that node list which we created and all the attributes which we created is a lot of extra. To create a bare minimum, right, you just provide the edge list. So the edge list, and by default, your graph will be directed, right, but you don't specify your vertices. So if you look here, basically what you could provide to your graph, to your data graph from data frame is just these two columns, right? If those two columns are provided, your graph will be able to, your function will be able to create a graph for you from the data. And then you can use extra steps to add attributes if you want, to have labels, just to add whatever you want in your graph, all right? Now, just make sure, because later we're going to do some visualizations for our graphs. So can you all make sure that you have your graph ready? All right? I will, good. Sivanji, do you still have an error or is it all doing well? Sivanji, how are you?
Yeah, hold it, Maria. I was doing some admin issues as well because, you know, just to like keep everyone on the loop, you know, some people haven't got emails due to the RMIT IT outage, and like I was also following on that. So I'm sorry if I'm, you know, slow on the chat. I was following up on that, and
all good, all good. I'm just checking with everyone so that we can move on to the next step. All right. So if you are there, so you should have that roots graph object created, and now we're going to work with a roots graph. So basically, we can forget about our edges and nodes. We can just move them away. We don't really need them. We're going to work with our roots graph object. So later, we're going to we can save the graph object. And you don't really have to go through all the steps later when you do your analysis. You can just load it straight from the format which you prefer. All right. So yeah, so write graph, really cool function. I really suggest that you run it now in case like something happens with your environment, you lose that. All right. So write graph, and you specify the graph that you'll be doing. All right. So roots graph. And you specify where it will be saved, what name they will be using. I suggest that format, GraphML, and whatever you save, whatever the file name you specify here will be saved under your working directory. So if I go back to my RStudio, so it's over here. Yeah, let's have a look. Let's zoom around. All right. So if I look under my files, now let's have a look if I can find one that right? So this is my object which I saved, right? So later I can just load it from the file, and I don't have to do any other manipulations, right? So it's always in your working directory, the working directory that you have for your project. and I hope it will work in the project, right? So if you're on the cloud, that will be saved on the cloud. That will not be saved on your desktop. So if you're working on the cloud and you run this command over here, so let me post it in the chat. So it's commented out, right? I don't really want to do it every time I run it. Just let me, so just can we also, because now everything is working for everyone, right? So can you just save your graph just in case, right? So we are saving it. Right, and if you're on the cloud, so I need to. So if you're on the cloud, all the files that you are saving there will be saved under your files on the cloud as well. There is a way for you to import and export your files, but that will be extra step for you. Right? So whatever I'm saving here, that will be saved under my project, and you can get access to there over here. Right? Now, later, if you want to come back to these and you don't really want to go through all the steps, what we need to do, we need to load our graph. So let's go and have a look how we do this. So to load our graph, so again, this line is commented out, but this is what you can do. So you don't have to do it now because you already have your object, but if you're having issues later, this is what I can do. So I have my iGraph object saved, and I can just pass that iGraph object to you, for example, in the chat, and you can load it in your environment later. So I'm using a GraphML format. You can save it to other formats which you prefer or your collaborator would prefer. All right, so it can do some conversion for you as well. All right, now, so let's have a look further into our object. So we came through this graph. So if we run a simple test, so if we run class on it, shows that it's iGraph. And now this is the notation that I have for my object. Now, so how do I read this? Right. So again, it's showing me my nodes and showing me my edges. So it gives me, so it's not a really big one, but it gives me some flexibility. Right, now it shows me my attributes. So, and you see I've got different types of attributes. Some of those attributes have VC, and some of those attributes have EN. What is that? So I've got vertices and I've got edges, right? And I'm adding attributes to each of them. So later, so I would not be using it in iGraph manipulation, but I will be using it later when we move on to gggraph. So I'm not quite sure if we can cover that today, but the gggraph is really cool. So we're probably going to start with that tomorrow. Right, so now let's move. So we're doing some basic exploration. We're not going to cover that, so it's already, so you did that with your family. So I'm running edges just to see like what are the edges, and I'm running vertices. So I do have IDs for my vertices. So I don't really want to deal with named graph over here. All right. Now let's have a look. So I've got names saved under like different attributes. So, but that's what I like here. All the edges here. All the edges, all the, right, now I don't have that, I don't have weight, but I do have names. So I can, if you remember, I can access all my attributes by the name. So in this case, in my edges, I don't have weight, but I do have a look, I got number of trips. So I can access attributes number of trips by referencing number of trips over there. All right, and now let's have a look at visualization of our graphs. Now our graph is pretty big, so we're going to have some time just trying to make it into good shape. We are not going to make it in a really perfect shape today because I would suggest that we go to gggraph for that, which will give you much cooler features on top. But let's have a look what can be done with a smaller graph. So the very basic visualization function that you can use is the very familiar plot function. So I'm just applying my roots, my roots graph to the function, saying that this is the graph they want to visualize, and now I'm supplying some additional parameters here. All right. So what is that? So all of this is like, if you look at a list, if you look at the help file for plot, it gives you a lot of different options to play around, and that may be good or bad. And to a certain extent, that's counteracted when they look at the gggraph library, when they say, just putting all the options here may not really be a good idea. So it may look cooler if we start introducing layers in our data visualization, and we work with different type of different layers in terms of how we present information. So edge arrow size, we've got vertices. We're not using vertex labels. Right? So vertices labels are set to, so we're not using them. Now, we also can have a look before we move on. So I showed you how you can save your graph. For some manipulations, you may want to save them back to your edge list. For example, if there is any other form that you converted, that you created your graph, and now you want to save it as an edge list. So we've got our functions for that as edge list, right? And you can have it as agency metrics, right? But it may like really, you know, big when you have like quite big graphs, right? Now let's move to next bit. So these are, so going back to plotting. So let's have a look. So these are all the options that you may have. So we can play with colors, with vertex colors, right? And you've got quite a few options for your nodes. And for your edges, you also have quite a few options here, right? So with colors, people usually like have a question like how I go with color. So with edge width, like it defaults 1, and then you can have a bit of flexibility in terms of what you can use. Arrow size, a bit of flexibility of what you can use. Some other options that relate to your graph. Again, you may you're going to have much more control over your graph when you start using your gggraph. So this is some basic plotting function. All right, so again, so here I'm showing you quite a few examples. So what I suggest that you may go with my examples. You may go like I'm just going changing some colors. So here in this example, for example, I'm changing colors for my nodes. All right, I'm changing some other things around. I'm introducing labels, I think. All right. So what I suggest that you try and use, so you go with the default one. So we start with this plot over here. So my task to you. So this is like here, this is my default plot. So I suggest, so I'm just gonna post it in the chat. All right, so this is the starting point. So what I suggest is like in next 10 minutes. So if you can start using 1 or 2 options from your nodes list and 1 or 2 options from your edges list to change your graph around and to see like how it's gonna feel. All right, so I'm going to make a bit smaller so that it's on the same screen. Same line, right? So if you can use that function as a starting point and change some options, some parameters related to nodes, and change some options related to edges. For example, you can change your edge width. You can change your edge colors. Well, it's, yeah, you're quite right. It's like it takes no time to get a really ugly one. And this is like, yeah, this is where we'll be changing it tomorrow when we look at much more advanced, when we look at gggraph. Let's see if we can make gggraph today. So when you have a like really big graph with lots of nodes, you may start thinking about like how to present in a better way. So there's a very big literature on terms of how you make your what to present in a graph and what not to present in a graph. Like now we're just playing around and just seeing what's available, what sort of parameters you can use, what colors you can use. But it's a really big science around that. So tomorrow we'll be showing you a couple of resources that you can use when you actually start presenting your graphs for communication purposes. Right? So how you arrange your colors, how you arrange your nodes, what are different layouts. So the best thing about using R is that you can choose so you can have a lot of flexibility and a lot of control in what can be done. So we're going to look at different layouts available for our graphs. So at this stage, it's just like a very straightforward, oh, well, we can picture that. But it's not as simple as that at all. So it's I'm just giving you this exercise to have your hands down with your, just to see like how difficult it is to get your graph to actually look good. Just changing the color is not going to make it. It's not going to communicate the message. You always need to keep in mind that putting your graph as a graph has a message as to present information to somebody. So what sort of information do you want to present? So my students usually struggle when they put a graph and they just put that and say, oh, no, that's the graph. I'll look at that. Now, but I can have a look at that, but what's the message I'm getting from this? So what exactly do we want to show? Do we want to show two different levels of service? For example, national and international, and they want to show connections. There will be one approach. So do we want to show what is the major stations in our transportation system? That will be a different message. So we also can, so with all the flexibility with node, colors, shapes, we can use it to assign attributes, right? So you remember we've got attributes. So how attributes are gonna kick in. So are we going to use different colors for different types of stations? Are we going to use different edge width for different edge attributes that we have? So all of these needs to have a lot of thinking. So like the exercise that we're doing now is just just try different parameters. Is not really the ultimate goal. The first step will be to sit down and actually think about what is the story that you want to present with your graph. So what exactly you are saying, right? So is it the initial data exploration, or is it the final communication piece that you are putting out there? So it's a lot of thinking about that rather than doing. So at this stage, we're just playing around with all the options available. So these are the basic options, right? And I do have quite a few examples when I work with this, right? So I have a look. I've got like really messy ones. So this is the bit when we're starting looking at some layouts available. So what are layouts? So they are particular algorithms. So with graphs, like you have nodes and you have edges. But the question here is that how do we put those nodes and edges together? How are we going to organize our nodes around that plotting area that we have? And this is where we start talking about different layouts. So again, big science around that is how we communicate the message. Forget about colors, forget about edge width, forget about those. How do we communicate the message? Just showing our graph in a way that people can understand what exactly is on the graph, right? So here, this is where graph network layouts become really important. So what are network layouts? They are algorithms that are used to coordinate nodes in a network. So the placement of those nodes in the plotting area, right? Now, iGraph do have like that flexibility. We're going to extend that further tomorrow when we look at the gggraph, but let's start with basic, right? So this is a good example of a random layout. So we are saying that we want to apply a layout randomly to our graph, right? And then we just present it with the how does it look? Very random, right? So all the nodes you see everywhere, and just because I'm putting labels on those nodes, it looks like awfully messy, all right? Awfully messy. Any message that I'm communicating with this? People just like, if I want to shock somebody, right? Right, a heart attack, what's there? I have no idea. I have no idea. It looks really messy, right? So, and just hopefully that's not the first work that you're seeing from your students, right? Now let's have a look. Again, let's try a different layout. Again, we're just trying things out, right? So tomorrow we're going to look at more science behind that and how we do this. So the next layout that we can try the circle layout. Again, nobody tells you where your nodes should be, right? It's all about like creativity in a way. So we're going to look at our circles, right? So we see all my nodes are presented in a circle, right? In a circle, and all the roots are here. So how does it look? No, not good at all, right? So you may think about, when you start thinking about which particular layout to use, there are certain layouts which are used like most of the time. And like the science tells you that they should work for most of the graphs, right? But sometimes you may need a different layout. So that circle layout, so layout in circle is, again, you specify the name of the graph and then you put in the plot. So a circle layout. Now, next one, we can have a sphere, all right? So let's do 3D. So how does it look? Those labels like really mess the whole thing up, all right? And again, like just because we've got quite a few stations, so if you look at how many nodes was that? So let's go back. So quite a few nodes. Oh, where is my notation? All right, so I've got, I think it's 115 nodes that I've got. Yeah, so I've got 115 nodes to present, and I've got 606 edges to present. That's quite a lot. All right, so this is where I might think about like 115. Do I want them all on one graph? or do I want to somehow filter them? Do I like with attributes? I don't really have that many, so but I can use those attributes to play up a certain bits, right? So 115 is quite a few. All right, so Richard, you tried this, so let's have a look. Let's have a look further. So let's have a look. So that's my which one is that? So that's my circle. So this is my sphere. All right. What science is saying? Science is saying that better looking graphs, like without looking into details, better looking graphs are usually done with force directed layouts. So force directed layouts is a big approach which looks into, they look at the graph as a physical system, right? So there's like, if you go back to your school math, your science, so electromagnetic fields, right? And they're thinking that those nodes that you have all over the place, they are electrically charged, right? And what is happening is like you're trying to move it around, so to move your nodes around in a way that it at the same time attracts, at the same time springs, all right? And they believe that that magic point where it springs and attracts will give you the best one. So the algorithm that are trying to simulate this, Person-Raymond, right, usually gives you the best possible layout. So there are usually when you are in doubt what to use, start with this one, all right? So let's have a look. So I'm just going to post in the chat, and this is the one that I want you to have a look at. Right. So if you can try to post that one with your chat, or in the one in the chat. So this is the bit where we're changing only the layout, right? So you can have all the other parameters which you played earlier. So any particular color schemes which you use, you still can use that one. And Richard was suggesting, so usually that one gives you the best looking graph. Not in this case, because we have too many nodes, which we're going to deal with later. And Kawai, so you mentioned, I have it on my here, but that's another one. Right. So have a look. So have a look at this layout. Oh. Yeah, there should be correction there. Right. So can you all have a look at your other parameters that you used? And we're moving on. So the next bit that we have a very quick look. So we are just not finishing with visualization. We're going to have a look at visualization further when we look at gggraph. All right. So at this stage, we're moving on to some measures. And we're going to look into measures further tomorrow when we work with the project further. All right. So we are going to look at density. So what is density? So we've got a function how to calculate density. The density is the proportion of present edges to all possible edges in the network. And to do that, so we'd use edge density on our graph. Right. So have a look at this one. So can you try and run this function over there? So to get edge density. All right, so now you may also want to have a look at reciprocity. Which is the proportion of reciprocated ties in a directed network. All right, so again, all right. Now we're also going to have a look at transitivity. So we've got some functions for local and global transitivity. So global transitivity will look at triangles. So global transitivity will look at the ratio of triangles to connected triples. And we also can have local ones. So tomorrow we're going to go with a project which we're going to move further into those dimensions, those measures for our graph to just make sure like how we're going to use them with practical applications. Now, finally, so some basic operations when we look at the diameter. So we'll look. So let's us look at the diameter. So we're looking at the network diameter, which is the longest distance. All right. So very simple. We go with diameter, and you specify the graph. All right. So we're going to go into those measures further tomorrow when we work with the project, just like the starting point. All right.
So Maria, just to double check, all these measures are for the full graph, we get one, right? So it's not by vertex or not by edge and, things like that. These are global measures.
Like, this is a very general, right? So this is a very general. So we're going to dig into measures tomorrow.
Yeah.
When we work with a particular project, so to have a look. We'll be working with the Twitter data, with the social media data to have a look at how it's like we're going to apply them.
Yeah, okay.
All right.
Thanks.
This is just to see what's happening there. All right. So that was the next library. So we looked at the iGraph library. Now let's have a look how. So we've got a small a little bit time left. So let me pull that next library we're going to use. Give me a second. Just give me a second. I'm just going to pull up things. Okay, so I'm just pushing it to GitHub so that you can have it over there. Okay, yeah, just give me. Okay, you should. So we're going to have a look at StatNet. All right, so you should be able to get that StatNet file over there. And let me pull it up. Right, now let me screen share. So now I have it. Okay, so that's the StatNet package. That's the next package that we're going to have a look at. Now it's much more massive than the previous one, than the iGraph that we had a look, and it covers a lot of extra things that you can do with your graphs. So it does so have a lot of modeling features. We're not going to cover them, so we're going to go through the mere basics. But like I will provide you with resources that you can use to use the package later with all the extra bits, right? So it includes several packages that are tailored particularly for network analysis. And again, it's available in lots of environments. So it's not only R. So quite a few other environments are covered, basically most of them. Right, so the one that we'll be working with basically with network package under that StatNet package, and we'll refer to SNA package, well, depending on if we have time. Most likely it'll be tomorrow. Now, some of the functions that we're going to cover we'll be comparing to the iGraph package. Now, StatNet page has a really fantastic resources, right? With covering all the functionality available in each of the particular packages. So if you're interested in any of the additional options over there, you've got access to that, right? So if there is any particular other area that you are interested in, so I'm also quite happy to help you get those resources for you, right? Now let's start with the network package, and let's see what we can do. Now again, so the very starting point for us will be to create a network object, and the network object in StatNet differs from the iGraph. There is a conversion that you can go from one object to another one, and you need just a separate library for that. Right. So in this case, we are going to work with the inbuilt data set. So in Florence, you know, there's a very, very famous family, right? So those Florentine families were very famous for their wealth and for their heritage and for their connections. So that family tree of those Florentine families is included as a database, as a data set flow, included in a network package. So we're going to have a look at that package now, at the database data set now. We're going to load it first. So before we move on and do any sort of operations here, you need to make sure that you go to your RState file, and you need to make sure that you install your package. So install packages, you need to install StatNet. right? And you need to make sure that you load that library. So again, as I told you, it includes many different sub-libraries. So the same way as you've got your titeverse. So just make sure that you have those two functions. Yeah, we're going to, Charles, we're going to work with the same root file when we're going to convert between iGraph and network object. So like that's gonna go definitely, like that's the next step, right? So again, but let's at this stage just load those libraries. Just make sure that you've got your startnet ready, right? Now the first step is just let's get our Florentine families. So it's inbuilt, so we're just pulling it up. So data, so floor is the name of the data set, and you're just creating an instance of that in your system. And then creation of the actual network object is quite straightforward. So you're using a network command under the network package, and you create the network object. So network, then you specify. So in this case, so if you look at the data in that floor data set, it's in a different format. So before that, we were looking at the edge list and nodes list. So now we've got agency metrics. So that's a different format that we supply to the function to create our network. Right? So we created so this is the agency metrics, and now we're saying it's not directed, right? And now if we run class function on this, so you see it's a different object. So it's an object network, right? So I just want you to I'm posting in the chat what exactly I expect you to run. So that you have this object in your environment. All right. Now this part here is a syntax, so you don't run it, right? So you don't run this bit. All right. So this is the syntax again. So it's much more massive library than iGraph. So you've got your network function, and then you supply, like in our case, that's agency metrics. It can be the edge list. So depending on what you have. So usually the input parameters are the same as what you use for your iGraph. Now, if you've got your attributes, you supply that as well to have it there. But you need to specify if it's directed or not. So it's directed by default. So if we need to change that, so don't forget to use the false, directed false. Right? So now let's have a look. So if we run summary, so summary is the basic function that we can get characteristics of our graph. So what do we see here? So it talks to you in a more like your human way, all right? So rather than iGraph, which gives you numbers and expect you to earn those numbers. So let's have a look. So in our network, we've got 16 nodes. So as we asked it, it's not directed. We don't have hyperlinks or looks, right? Now, total edges, we've got 20. So it's 16 nodes and 20 edges, right? Now, it already provides you some parameters. Now, what about attributes? We don't really have, we don't have anything. And now this is your edge list, right? So with all the connections. Now, StatNet comes with two really cool functions to show your graph, all right? So the easiest, like very straightforward one, if you want to have a very, very quick look, ggplot, right? So if we run ggplot on our family, so like you see, we're much less messy than the one that we looked at. Why? Well, because it's smaller. All right, so you don't have that struggle. So the bigger the plot grows, the bigger the graph grows, the more other problems that you have arranging the plot. So let's have a look. So we're running a ggplot on our family. All right, we're specifying our colors, and we're saying that we want to display labels. So these are all the families. So any familiar? Have you watched that movie, Medici? There was a very famous series. I don't really remember the actual name, but yeah, so that was my lockdown pastime. There's something to entertain kids so that I can work. All right, so I'm going to post this in the chat. So I really want you to have a go at that. All right, so we're not specifying the layout, we're just very, very simple. It's a lot, yes, I love like ggplot is like really a quicker way of just having a look at your graph. So that's from SNA package. And if you usually run, well, if you want to use your visualizations for communication purposes, you need to put much more thought than just simple ggplot. But ggplot allows you to see like if it's really working the way that you sort of like do around a graph, right? So you use ggplot anytime that you want to test it. So I would say the minute you loaded your graph, just test it with ggplot, right? So looks good, right? Now let's have a look. So we also can work with edges, and we also can work with nodes then, right? So let's have a look. There was a question, so we're going to initialize. So we're going to start from the scratch, and we're going to start with an empty one. So let's have a look. We're going to create a new graph, and we're going to use network initialize. You remember that's different. So we'll use network just to when we've got some other forms, adjacency metrics that we want to use, or age lists that we want to use. If we don't really have anything, we just start from the scratch, we use network initialize. So I am setting up 5 nodes for my network, and basically that will be empty. So a new network, let's run it. All right, so I'm putting it in the chat. All right, so it's over there. And if I run a summary, so a class network, and if I run a summary on that, so I've got 5 nodes, but I don't have edges, so it's all empty. All right, so I don't really have any connections. I don't have anything of those attributes or anything set up. It's just like empty. All right, so if I run my ggplot on this, so I've just got like 5 nodes and that's it. All right. And you see names, I don't really have, so labels are just, yeah, just like as they are. Now let's move further. So what I'm going to do, I'm going to add edges, all right? So how I'm adding edges, let's have a look. So I'm adding edges, I'm saying that my network is a new network, and this is what I'm doing. So let's have a look. So I'm adding an edge from 1 to 2, and I'm adding an edge from 4 to 5. So let's post in the chat and let's have a look. All right. So now, when I run this, so I have a look. If I run my summary command, so I still have the same number of vertices, but now I created 2 new edges. All right. So, and now if I look at my adjacency matrix, so I have a look what my adjacency matrix is saying. I created my edge between 1 and 2. So 1 to 2 is 1. No, so it used to be all 0, so now it's 1. And now if I look at 4 and 5, so 4 and 5 also have 1. So I create this one. And if I quickly run my Gplot on this, all right, so I've got my edge between these two. Right. Now let's move further on. What if I need to remove the edge? Just 0 it. All right. So if I want to, so like here, this one, so 1 and 2, if I want to erase this, so what I'm doing, I'm just saying it equals to 0, it equals to none. All right. So I am removing it. Now it's gone. All right. Now let's have a look. Again, so you can get some basic information about the size. You can get some basic information about the edge count, which we looked at previously. All right. So network edge count, and you specify network size, you specify the graph. All right. Now let's have a look at edge vertex attributes. All right. So with vertex attributes, I've got only 5 minutes left, so let's see how we go. All right. We're going to look at that, but I'm not quite sure. We've got only 5 minutes left. I'm not quite sure if we're going to look at that today. All right. So here, so we will look at nodes attributes, and like if you look at the documentation for a StatNet, so StatNet is very particular that in all references they use vertices, not nodes. So you go to iGraph, so iGraph usually refers to nodes as nodes. All right. So if we want to get attributes, so if we already have some attributes set, so then you just use get attributes. Now, what am I trying to do here? Right. So we are looking at the special annotation. So we're looking at the shortcut, which is very particular to StatNet, right? So this is where we work with the vector of attribute values, right? So we are saying that we are assigning, so we're setting that attribute value to our vertex, right? So, and we're using letters, like between 1 to 16. So we are assigning it to the attribute. And now when we're pulling this off, it's here. All right. So this is very particular. So this is very particular part, which is relevant to just StatNet. Okay. I've got some examples here, which you may want to go, but we're going to start with visualization using all the functions there tomorrow. All right. So we've got like a couple of minutes left. So I think we just stop here.